Question 2b. Discuss the convergence of the following. First question, series n is 0 to infinity 4 raised to n plus 5 raised to n upon 6 raised to n. Second question, series 2 raised to n upon n raised to 3 plus 1. Now these two question carry 4 marks. मतलब कि हर एक क्वेश्चन के कितने मार्क्स है? 2 marks. Okay. Now let's discuss the first question. Now here observe the term of the series. In this series power n is given. Okay, 4 raised to n, 5 raised to n, 6 raised to n. Okay, so here power is given. Okay, power of n is given. So that's why here we apply root test. Now this question you can solve using either root test, and second is using the geometric series. Okay, but here the question is that only discuss the convergence of the series. यहाँ पे आपको सिर्फ कन्वर्जेंस चेक करना है, आपको यहाँ पे सीरीज का सम नहीं फाइंड करना है. ओके, सम इज नॉट आस्क. ओके, सो दैट्स व्हाई हियर वी अप्लाई रूट टेस्ट. अगर आपको सम भी फाइंड करना होता तो आपको क्या अप्लाई करना है? ज्योमेट्रिक सीरीज. ओके, सो हियर ओनली वी आर इंटरेस्टेड टू फाइंड द कन्वर्जेंस ऑफ द सीरीज. हियर we are using root test. So now first of all what to do? First simplify the general term. So this is the n term of the series, 4 raised to n plus 5 raised to n upon 6 raised to n. Now separate the denominator. So what we get? 4 raised to n upon 6 raised to n plus 5 raised to n upon 6 raised to n. Now here 4 and 6 even term. Okay, so that's why here 4 we can write 2 2s are 4. So raised to n, and 6 2 3s are 6 raised to n plus 5 raised to n upon 6 raised to n as it is, because here 5 is the odd number. Okay, so here from this we cannot find any common factor, so that's why put this term as it is. Now separate the power n. So 2 raised to n multiply by again 2 raised to n. Okay, in denominator 2 raised to n multiply by 3 raised to n plus put this term as it is. Now this 2 raised to n cancel out. So what we have? 2 raised to n upon 3 raised to n. Here power is same, so that's why take the common power. 2 upon 3 whole raised to n plus same here 5 upon 6 raised to n. Okay. So here we separate the term. So now the series 4 raised to n plus 5 raised to n upon 6 raised to n can be written as a sum of two series. First is series 2 by 3 raised to n plus second series is 5 by 6 raised to n. Okay. So now our given series is a sum of two series. So to find the convergence of this series, what we need? We are interested to find the convergence of this series and convergence of this series. Okay. So as per the rule, if this series and this series both are the convergent series, then what we conclude? The given series is convergent. And if two series are divergent series, then what we conclude? This given series is what? Also divergent. Okay. So now convergent of this series is depend on the convergence of this series and this series. So now let's find the convergence of this first series using the root test. So first of all, what is the root test? For root test we need to find the limit L, limit n tends to infinity, nth root of mod un. Okay, here un is what? Nth number of term of the series. So for our series, nth number of term is 2 by 3 raised to n. So this is the positive term. Okay, so what we get? Positive term. That's why after removing this absolute value, we get 2 by 3 raised to n, and this is the nth root. Okay, so that's why write 1 upon n. So now n is cancel out. Answer is what? 2 by 3. Okay. So here for root test, what is the condition? If limit L is less than 1, then the series is what? Convergent. If L is greater than 1, then the series is what? Series is divergent. And if L equal to 1, then what we conclude? The test is fail. Okay, or we cannot say anything about the series, whether the series is convergent or divergent. Okay, so now here 2 by 3, what is the limiting value? 2 by 3, and 2 by 3 is less than 1. So from this what we conclude? The given series converges. Okay, so this first series is what? Converges. Let's find the convergence of the second series. Okay, series n is 0 to infinity 5 by 6 raised to n. So again apply the limit. L2 is equal to limit n tends to infinity nth root of 5 by 6 raised to n. So again n is cancelled out, we get 5 by 6, and 5 by 6 is again less than 1. So from root test what we conclude? The given series converges. Okay, so that's why कंक्लूजन के लिए हम यहाँ पर एक प्रॉपर्टी यूज कर रहे हैं. इफ सीरीज an converges and series bn also converges, then series an plus bn also converges. Okay, so use this property. This series converges and this series converges, so the sum of the series also converges. Okay, so what is the conclusion? Since both series converge, the given series converges by the root test. Let's discuss the second question. Here the second question is what? Series n is 1 to infinity 2 raised to n upon n raised to 3 plus 1. Now here observe the term. This term contained 2 raised to n. Okay, so here power of n. And in denominator it contained polynomial. Okay, so that's why to check the convergence of this series, here we are using ratio test. Okay, so now what is the ratio test? For ratio test, first of all we need to find the limit. Limit n tends to infinity un plus 1 upon un. Here un is nth number of term of the series and un plus 1 is n plus 1th number of term of the series. Okay, so here this is my un. How to find un plus 1? Here n is replaced by what? N plus 1. Okay, so we get un plus 1. So limit n tends to infinity, un plus 1 is what? 2 raised to n plus 1. Here n plus 1 raised to 3 plus 1. Divide by un. So un means this term as it is, 2 raised to n upon n raised to 3 plus 1. Now here do the cross multiplication. So what we get? Limit n tends to infinity. Here 2 raised to n plus 1. So can we write 2 raised to n into 2? Okay. And here in denominator n plus 1 raised to 3 plus 1. Now do the cross multiplication. So here n raised to 3 plus 1 and in denominator we get 2 raised to n. So now this 2 raised to n is cancelled out. We have 2. From this take n raised to 3 common. Okay, so n raised to 3 is outside. 1 plus 1 upon n raised to 3. Similarly from this take n raised to 3 common. So first of all n raised to 3 common, 1 plus 1 upon n raised to 3. Here from this take n common. So that's why here raised to power 3 is given. So that's why n raised to 3. Okay, n raised to 3, 1 plus 1 upon n raised to 3 plus 1. Now 2 as it is, this numerator is as it is. Now from denominator, from the entire term, take the n raised to 3 common. So n raised to 3 outside in big bracket, 1 plus 1 upon n raised to 3 as it is plus 1 upon n raised to 3. Okay. तो पहले हमने क्या किया है कि ये n+1/3 में से हमने n कॉमन लिया, सो दैट्स वाई इट बिकम n/3। अब सेकंड हमने क्या किया, तो ये एंटायर टर्म में से हमने n/3 कॉमन लिया है। ओके, नाउ दिस n/3 is cancel out and apply limit. So this 1/n becomes 0. So after simplification, what we get? Answer is 2. Okay, so what is my limiting value? L is 2. Now for ratio test, what is the conclusion? If limit L is less than 1, then what we conclude? The given series is convergent series. Okay, if this L is greater than 1, then the series is divergent series. And if L equal to 1, then the test is inconclusive. मतलब कि हम सीरीज कन्वर्जेंट है या डाइवर्जेंट कुछ भी L इक्वल टू 1 के लिए नहीं कह सकते। ओके, सो हियर व्हाट वी गेट, हियर L is 2 and 2 is greater than 1. So from this what we conclude? The given series is divergent series. Or option, question number 5b, discuss the convergence of the series 1/1 plus 3 plus 2/1 plus 3 square plus 3/1 plus 3 raised to 3 plus 4/1 plus 3 raised to 4 plus so on. Now this question carry 4 marks. Okay, so now the question is to check the convergence of the given series. For this, first of all, we need to find the general form of the series in form of n. Okay, so now let's start solution. Let the given series is written as series n is 1 to infinity un. Okay, so now here what is the general form? Now observe the numerator and denominator. Here in numerator 1, 2, 3, 4 and so on. Okay, so that's why in numerator write n. N is vary from 1 to infinity. Now observe the term in denominator. 1 plus 3, 1 plus 3 square, 1 plus 3 raised to 3, 1 plus 3 raised to 4 and so on. Okay, so here 1 is fixed, 1 plus 3 raised to power n. Okay, because this is my series. Now what is the nth number of term? Nth number of term un is equal to n upon 1 plus 3 raised to n. Okay, now to find the convergence of this series, observe the term. Here raised to power n is given. Okay, but here it is not the separated form. This power is connected by addition term. Okay, so that's why here we cannot use the root test, but instead of root test here we are using ratio test. Okay, so if power of n is given, either you can apply ratio test or you can use root test. Okay, but here 3 raised to n is written in algebraic equation. Okay, so that's why here I am using ratio test. So for ratio test, first of all compute limit L. Limit L is equal to limit n tends to infinity un plus 1 upon un. So here what is the un plus 1? In this n is replaced by n plus 1. So un plus 1 we get n plus 1 upon 1 plus 3 raised to n plus 1 upon un is as it is. Okay, so n upon 1 plus 3 raised to n. Now simplify this term. So n plus 1 upon 1 plus 3 raised to n plus 1 as it is, and here after cross multiplication we get 1 plus 3 raised to n in numerator and n in denominator. Okay, so we have this form. Now first of all from this take n common. Okay, so what we get? N 1 plus 1 upon n can we write? Okay, from this take n common. So n 1 plus 1 upon n, and in denominator we have n. Okay, so that's why n is cancel out. What we get? 1 plus 1 upon n. Okay, so write this one. Now here separate the power of 3 raised to n. Okay, so can we write 1 plus 3 into 3 raised to n? Okay, now I have this term. 1 plus 3 raised to n upon 1 plus 3 into 3 raised to n. Okay. Now from this take 3 raised to n common. Okay. So I am taking 3 raised to n common from numerator. So what we get? 1 upon 3 raised to n plus 1. Okay. In denominator again take 3 raised to n common. Okay. So 1 plus 1 upon 3 raised to n plus 3. Okay. So I am having this term. Now this 3 raised to n is cancel out. So what we get? 1 upon 3 raised to n plus 1, and here 1 upon 3 raised to n plus 3. Say yes or no? Okay. Now apply limit n tends to infinity. So this term becomes 0. Also this term and this term become 0. Okay. So what we get? 1 into 1 upon 3. So what is my limit? Limit L is 1 upon 3. Okay. So from ratio test, what is the conclusion? If L is less than 1, then the series is what? Convergent. If L is greater than 1, then the series is what? Divergent. And if L equal to 1, then we cannot find any conclusion. Okay. So this test is fail for L equal to 1. Now here 1 upon 3. So 1 upon 3 is less than 1. So what we conclude? From the ratio test, we conclude that the given series converges. Okay.